Hey there! So, let's dive into a problem that may have caught your attention while playing around with std-ranges views. The issue at hand involves the sizes of chain views, where each view seems to get bigger, especially with functions like transform and filter. It's interesting to note that while the transform view doesn't increase in size at all, the filter view increases by an unpredictable amount, creating a bit of a mystery. Now let's talk about the solution to this intriguing problem. The key lies in understanding how filter_view operates. In order to maintain the amortized constant time of ranges, the filter_view needs to cache the first iterator of the underlying view that matches the predicate. This caching mechanism ensures that repeated seeks are avoided, thus maintaining performance. Consequently, the increase in size of the filter_view is due to the internal cache that stores the iterator of the underlying view. It's worth noting that the function object is stored within the filter_view itself, leading to an additional pointer in the iterators of both filter_view and transform_view. This pointer facilitates access to the function object, adding 8 bytes to the size of each iterator. As a result, these views are never considered borrowed_range to prevent issues with dangling pointers upon destruction. Understanding these internal mechanisms sheds light on why the sizes of views behave the way they do in this context. In summary, we've explored the interesting behavior of chain views in std-ranges views, focusing on the size variations observed with transform and filter views. The solution lies in the caching mechanism of the filter_view, which stores the iterator of the underlying view to optimize performance. By grasping these internal workings, we gain a deeper insight into the complexities of view sizes in the context of a C++ ranges library. Thanks for watching, and remember to subscribe, like, and drop a comment below with your thoughts on this puzzling view behavior. Happy coding!